Everybody, Harold here. This is the fourth video in the secure hashing cybersecurity series for Python. This one is about argon2. It's the gold standard in secure hashing. It's one of the strongest algorithms. There was a contest in 2015 and it actually won it. It's memory hard, CPU hard, and I have trouble saying this word, parallelizable. That just means it can run on many different threads. Um, it makes it very resistant to brute force attacks. The great thing about argon2 is in like bcrypt and scrypt and hashlib, which we've seen before. You had to make your salt and etc. Argon2 does everything for you. We'll cover usage verification, auto rehashing, which is awesome, parameter tuning, and secure storage. So to get it, we'll bash pip. Since I'm in collab, I have to bash with the exclamation point. Pip install argon2-cffi. I've already got that satisfied. Let me clear that out of there. Basic hashing from argon2, you import password hasher. Then you create a password hasher object. Convention is ph. So ph equals password hasher. Hash the password. Mine is, again, my super secret password with a super secret $123. And you say the hash equals ph password hasher dot hash, and then you hash the password. So to show what happened, we'll print the password and then the hash password. So password was my super secret password 123. Argon2 turned it into this. And what it is a string with all the parameters, salt, and the hash. So this is what I said. It's really cool. This is convenient. You don't have to store the salts separately. The parameters are right there where everyone can see them. Version, well, it breaks down like this. Um, the algorithm, which version of Argon you're using, how much memory is going to be used. So 64 megs of RAM. How many iterations is T? How many threads parallelism is 4? And then the salt and the hash are all contained in this string. A random 16-byte salt and a derived hash key. So we've hashed that password. We want to verify it. It's always good when you're getting user input to catch errors. So we'll do it in a try except block. Argon2 has built-in exceptions. The base class is verification error. It's got verify mismatch error, and I think there's another one. But from argon2 exceptions, import the verify mismatch error and verification error for this demo. And then we'll try to verify the hash, ph verify, hash, my super secret password 123. If it's okay, we'll thumbs up okay. If there's a verify mismatch error, we'll thumbs down. Password doesn't match. And if there's a general verification error, we'll thumbs down. Verification failed for some other reason. So let's try to decrypt, verify. Not decrypt, just verify with hash. That's okay. If I say change this to my super secret password 123, it triggers the verify mismatch error, and I get password thumbs down. Password does not match. uh, automatic rehash. This is really cool. If your hashing is weak and you need stronger parameters, you can check it, and argon2 will tell you if it's secure or not. So you could say if ph.check needs a rehash, your hashed password, we'll print hash needs rehashing for stronger security. If not, if it's okay, we'll say it's secure, it's locked. So for demo, I made an insecure hash. We'll run this cell. Weak password hash. It's password hasher, small time cost, 8 bytes of RAM, 1 thread. So that's pretty weak. I'll show you the parameters. That's really weak. I'll show you the parameters in a second. So weak hash is weak. So now weak hash equals weak th dot hash. We'll just use password 123, and we'll print weak hash and its hash. So that's an insecure hash right there. Looking at it, you see the 8, the 1, the 1, very low numbers for the parameters. So we'll check if that needs to be made stronger. And if ph check needs rehash, we'll check the weak hash. Same as up here. It's going to say it either needs rehashing or it's secured. Uh, we made it weak. ph check says, oh, it's weak. Your hash needs rehashing for stronger security. I really like that. Uh, but the parameters, tuning the parameters, it's a balance between cost and security. So pH is password hasher. It has default parameters when you just use it up here. The 64 megs, 3 iterations, 4 threads. But we'll go with the basic and hash. Now, if you mess with these parameters, you're going to uh, mess with your time and security. And here's a demo of the cost of changing the parameters, how increasing them affects hashing time. And we'll use argon2 import a password hasher, and we'll need time to time it. And we'll just say the password is Harold123. And then I'm going to make a list of configurations, parameters to test timing. So the first one is 16 megabytes of RAM. Second one is 32 megabytes of RAM. Third one is 64 megabytes of RAM. Um, they're running 2 iterations on 2 threads, 3 iterations on 2 threads, and 4 iterations on 4 threads. So we'll print what we're doing, and then for I, and config and enumerate. Configs will start at 1. You don't have to write all it. You don't feel like you need to type all this as I'm doing it. I'm going to put it in the GitHub repository. Just follow along. The time cut, we'll set the parameters to loop through these, try them one by one. So time cost is the time cost configuration. 1, 2, 3, memory cost, parallelism, etc. Then start time equals time.time. Then we'll make the hash password with ph.hash password and end time. And elapsed time will be end minus start. And then we'll print the time cost, the memory cost in kilobytes, parallelism and the elapsed time in seconds. So let's just run that. So argon2 hashing time to configuration 1, the time cost was 2. We used 16 megabytes of RAM on 2 threads. It took 0.03 seconds. Fig 2, the time cost was 3. We used 32 megs of RAM on 2 threads, and that went up to 0.08 seconds. We really ramped it up for iterations, 64 megs of RAM, 4 threads. Well, that took 0.212 seconds. So the higher these values are, the more memory and time you're using. So that's about it for argon2 basic. I'm going to give you an example. Full registration login here. We'll import password hasher and the errors. And PH's password hasher. Let's use Harold123. We'll store it, print the stored hash. Then we'll make a verification login function. So def verify password takes 2 arguments, the stored hash and the user's attempt. And because we're interacting with the user, we'll put it in a try except block. So we'll try to return ph verify stored hash and attempt. Compare the stored hash to the hashed password attempt. If it doesn't match, we'll verify mismatch error. Say it doesn't match and return false. If there's any other error, we'll say it failed for some other reason and return false. And we'll print. To test it, we'll put in error 123 and that'll see correct. And we put in wrong pass. Of course, that's going to say wrong. That should work. Correct. True for error 123. Password does not match. Verify mismatch error. Wrong. False for wrong pass. Put in Harold 1234. It's still correct because I didn't change that, but it's false. It doesn't match, etc., etc. Then for you to kind of play around with your own, I've got an advanced putting it all together. Configuring a password hasher with strong parameters, storing, registration, login, etc. You guys can play with that one on your own. Yeah. But overall, for secure password hashing, I've got a table here. Argon2 is the best. Let's just run over this real quick. I've got the hashlib secure hashing algorithm 256, got bcrypt, scrypt, and argon2. What they do, it's general purpose password hashing, key derived function password hashing, and key derived function password hashing. The salt is manual in hashlib, it's built in bcrypt, it's manual in scrypt, it's built in argon2. Hashlib is not memory hard, bcrypt is minimally memory hard. scrypt is good, argon2 good. For your CPU hard, hashlib is easy, but you want it to be CPU hard to be more secure, so these other three are more secure. There, you can only run one thread in hashlib. The rest take more than one for parallelism. You have to manually loop for iterations in hashlib. You can adjust in bcrypt, scrypt, and argon2. All these parameters. Security is low. Brute force forcible for hashlib. Medium to high for bcrypt, high for scrypt, very high for argon2, recommended for passwords. Use cases, checksums, file integrity, non-password data, stuff you don't really care about. Bcrypt, password storage and login. scrypt, password storage and deriving keys. And argon2 storage, key derivation, and secure authentication. Hashlib's built into Python, which makes a little plus. So is scrypt because it's part of hashlib. Bcrypt and argon2, you have to import the library. Install the library to port it. Um, uh, Hashlib's easy to use. Bcrypt's easy to use. Script's moderately hard. Argon's easy. It gives you more parameters, but I think that's better. So notes, hashlib .256 is fast, not suitable for password storage without adding the manual salt and iterations. bcrypt's solid, widely used, but its memory hardness is low. scrypt is memory hard and configurable for higher security, but argon2 is the modern standard, highly configurable, memory and CPU hard, built-in salt, simple to verify, and I like the auto rehashing. I should add this to that list. So that is argon2, the gold standard in secure password hashing. Hope you like this. I think we'll move on to cryptography and coding and decoding. If you did like this, please like it, subscribe, and I will see you next time. Thanks, everybody.